Welcome back. So we have made some pretty good progress in our discussion with normal curves and normal distributions. We looked at the standard curve with the mean of 0 and the standard deviation of 1. That was the first section there. We looked at general normal distributions, and most recently we looked at sample distributions and how they can form normal curves. Well, next up, we're going to do something a little bit different. We're going to start looking at not individuals, but samples and see how they relate to an overall distribution. So it sounds wildly complicated, but it's going to end up being just a simple twist on what we were doing in 6.1 and 6.2. So let's just do a review real quick, make sure we remember and understand all the basics from so far in our discussion on normal curves. Suppose that for humans, our internal body temperature is normally distributed. That's got a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.62 degrees. So my question to you now is, what is the probability that one randomly selected person has a body temperature of 98.2? And from there, let's do just a little bit of probability analysis and determine what's the probability of having 10 people in a row being randomly selected and having a body temperature of 98.2 or less. All of them. Well, for the first part, we are going to have to use the fact that this is a normal distribution and find a z-score. So we'll standardize our values with a z-score there. We'll subtract away the mean, divide by standard deviation, gives us negative 0.65 as our z-score. We then pull up some z-tables somewhere. Mine, of course, comes from ztable.com, not sponsored by them, but it's just the one that comes up when I Google z-table. And I get 0.2578 is my probability of being below that z-score. So my probability of being at 98.2 degrees or below, 25.78%. And of course, to do all 10 in a row, that is where we take that same probability and multiply it 10 times over. And that comes to be about 1 in a million. You got a 1 in a million chance of pulling 10 people and having all of them be with a body temperature of 98.2 or below. And that's just the basics here. But let me ask it to you this way. What if I don't want it so that everybody is at 98.2, but rather if I took everybody's temperature and averaged it, specifically got a mean of those 10 people, what's the probability that that mean is 98.2? So it might well be higher, right? Because previously, if I had one person with a temperature of, say, 98.3, that would throw it out. That would throw out the whole thing. But now, in looking at the average or the mean specifically to be 98.2, I am allowing for those cases to happen. And so this probability should be higher. And to find that probability, we are going to use what's known as the central limit theorem to find the probability or proportion or area, all of those things for a group of people. And so I'll say this and then we'll stop. You can use what we're about to talk about when two things happen, one or the other. Either your overall population is normally distributed, or you've got at least 30 people or 30 values in your sample. If you have either of those, both would be ideal, but if you have either of those, you're going to be able to do what we're about to do with the central limit theorem. And so we will get into that here in the next video. I'll see you then.